CBSE Mathematics Class 12, Exercise 5.1, Question number 34. Find all the points of discontinuity of function defined by fx equal to mod x minus mod of x plus 1. The given function fx is equal to mod of x minus mod of x plus 1. The two functions g and h are defined as gx is equal to mod of x and hx is equal to mod of x plus 1. Then function will be equal to g minus h. The continuity of the g and h are examined first. Gx is equal to mod of x can be written as gx minus x if x is less than 0, gx is equal to x if x is greater than or equal to 0. Clearly, g is defined for all real numbers. Let c be a real number. Case 1, if c is less than 0, c is less than 0, then gc is equal to minus c. x के जगह पर minus c रख दो. And limit x approaching to c, gx is equal to limit x approaching to c minus x, that will be equal to minus c. Therefore, the limit x approaching to c, gx equal to gc. That implies that g means function g is continuous at all points x such that x is less than 0. Case 2, if c is greater than 0, then gc is equal to c and limit x tends to c, gx will be equal to limit x tends to c, xc, x is equal to c. Therefore, the limit x tends to c, gx is equal to gc. Therefore, the function g is continuous at all points x such that x is greater than 0. Now come to the case 3. If c is equal to 0, then gc is equal to g0, that will be equal to 0. The limit x tends to negative 0 means left hand limit hai. Gx equal to limit x tends to negative 0 minus x equal to 0. Limit x tends to positive 0, gx, limit x tends to positive 0, x is equal to 0. Therefore, the g is continuous at x is equal to 0. From the above three observations, it can be concluded that g is continuous at all points. Hx equal to mod of x plus 1 can be written as hx is equal to minus bracket में x plus 1 if x is less than minus 1. X plus 1, hx will be equal to x plus 1 if x is greater than or equal to minus 1. Clearly, h is defined for every real number. Let c be a real number. Case 1, if c is less than minus 1, then hc is equal to minus in bracket c plus 1. x plus 1 की जगह पर हमने c plus 1 रखेंगे. And limit x tends to c, hx equal to limit x tends to c minus x plus 1 ब्रैकेट के अंदर, that will be equal to minus c plus 1. Limit x tends to c, hx is equal to hc. Therefore, the h is continuous at all points x such that x is less than minus 1. Now come to the case 2. If c is greater than minus 1, then hc is equal to c plus 1 and limit x tends to c, hx, that will be equal to the limit x tends to c, x plus 1. So it will be equal to c plus 1. Therefore, the limit x tends to c, hx is equal to hc. Therefore, h is continuous at all points x such that x is greater than minus 1. Now come to the third case. If c is equal to minus 1, then hc is equal to h in bracket minus 1, that will be equal to minus 1 plus 1, and it will be equal to 0. Limit h tends to minus negative 1, hx, that will be equal to limit x tends to negative 1, inside the bracket write down minus x plus 1, bracket close, minus, इन ब्रैकेट में लिखिए माइनस 1, क्योंकि माइनस 1 पर जा रहा है, माइनस 1 प्लस 1, दैट इज इक्वल टू 0. लिमिट h टेंड्स टू पॉजिटिव 1, hx इक्वल टू लिमिट x टेंड्स टू पॉजिटिव 1. पॉजिटिव 1 हमेशा राइट हैंड लिमिट के लिए होता है. x प्लस 1, दैट इज h माइनस 1 ब्रैकेट में क्लोज है, minus 1 plus 1, that will be equal to 0. Therefore, h is continuous at x is equal to minus 1. From the above three observations, it can be concluded that function h is continuous at all points of the real line. G and h are continuous functions. Therefore, function f is equal to g minus h is also continuous function. Therefore, function f has no point of discontinuity. That's all.